Welcome. This is Andy Marino from AME, Microbiological Surveillance Systems. This presentation is entitled Enhanced Food Safety, From Ship and Pray to Test and Release. This short presentation will review how traditionally food producers have screened their production for human pathogens. In this slide, slide 2 of 6, we see the few hours from the field to the market is occupied with the collection of the product from the field, usually a fresh leafy green, to a processing plant, and then to the product shipment in the matter of a few hours, with a number of maintenance and safety guidelines adhered to. Additionally, many of these traditional food producers perform what is known as traditional microbiology or culture tests, the results of which are available for human pathogens in anywhere from 4 to 14 days. Obviously, during that wait time, the product has been shipped, and this product, if it is determined to be contaminated with these organisms, usually E. coli, Salmonella, Listeria species, then a recall is then engaged in accordance with FDA regulations. This protocol has been named as the ship and pray mode of operations. It is fraught with challenges. It is historically what has been used, but this is probably going to change with the advent of the new Food Safety Modernization Act of 2011. On slide 3 of 6 is another graphical illustration of a potential modification to the ship and pray model. This I have labeled as the test and release mode of operations. The same collection of the product from the production area to a plant processing protocol in the matter of a few hours. At the end of that finished goods process, or anywhere in the interim, a sample is collected and run through a polymerase chain reaction type test. That test returns a result in about an hour. If those results return a result which is termed as a non-alert, and that is within acceptable parameters, that product is not contaminated, then the product is shipped to the market with no later recall potentiality. On the other hand, if the product is identified in that batch as having an alert for the potential contamination of human pathogens in the product, that product is held from the market either for further testing or for destruction. Thus the moniker test and release, or hold and release. Slide 4 implements graphically and illustrates how the collection of this data over the period of production establishes a statistical process control methodology for analyzing the risk. This is also known as periodic testing of randomized samples against established upper control limits. In this graph, we see a hypothetical range of test averages and a hypothetical average number of hours, in this case a 20-hour production cycle, and an upper control limit which has not been reached. This offers substantial improvement over the traditional methodology because the test results are returned in about an hour in almost an immediate screening or a surveillance of the product prior to shipment. In this test and release surveillance model, a number of sample sources can be identified, whether it's the irrigation water, the pre-harvest sample, the post-harvest sample, the product wash water, or the finished goods. All of these samples can be tested or selectively tested by management either through a total bacteria screen assay, which would detect any form of bacterial contamination. If then there is an alert, then we can go on to secondary screening. If there is no alert, then that product can be released to the market. Obviously, the more test points, if all 5 test points are engaged, then we have more confidence. If 1 test point is engaged, then we have some confidence. And anywhere from 0 with no testing to 100% can be achieved. And depending on the number of samples collected and the type of biological samples collected, then our confidence obviously would increase. Should the total bacteria screen return an alert, then a next logical course of action would be to run a panel of assays or tests, one for E. coli species, another for Salmonella species, Listeria species. If the latter of those 2, Salmonella Listeria, should return an alert, then that sample should be rerun for further confirmation testing, either through traditional microbiology or other technologies. And then that product should either be restricted or released to the market. If it's an E. coli assay, on the other hand, an alert for any type of E. coli organism within that family, then perhaps the following test could be run for the pathogenic varieties. Shigatoxin 0157H7 E. coli under the FDA BAM methodology may be a logical alternative, as well as, if that returns a non-alert, for the big 6 pathogenic E. coli 0145, 011, 026, 045, 0121, 0103. This model of test and release seems to be a statistically viable model to assure that a safe product has been distributed to the market. For further information, feel free to contact me, Andy Marino, at the following information. Thank you so much for your time.